Guys, it's me. Today, we're going to jump into a subject that a lot of students just don't like because it sounds scary. It's not tough. Don't let the wording to it throw us off. So today we're talking about imaginary numbers and understanding what's happening there. All right. The key to this whole idea is that every quadratic has two answers. Two. It's x squared. It's got two answers. That's going to be a big part of this. We talked in our last video about this, that what happens if you have a parabola that looks like this? When we're talking about solutions, solutions are where it crosses the x-axis, but it's never going to happen if the parabola is above it. So if we wanted to solve x squared plus 1, we would subtract 1, and it's just not going to work. So that's where imaginary numbers came from. All right, so I'm going to put this video that I'm looking at right now in the notes as well, but this is a really good video if you have a chance, if you want to know more about imaginary numbers. I'm just going to kind of go to some screens here, but it's a great video of visualizing what's happening here. And so some teachers, and maybe in Algebra 1 you said this, there is no solution to x squared plus 1 because it doesn't cross the x-axis. But that breaks what we said, that every x squared equation has two answers. Okay, this idea that every polynomial of degree n has exactly n roots. So for example, it's x squared, so it has two roots. That is called the fundamental theorem of algebra. That's a big sounding name. It's a true statement that has to be true. All right. And that squared means we're going to have two roots. Let me fast forward here. All right. So everything we know so far lives in this one world. Let me actually play this part here. 2,000 years. So imagine it doesn't cross the x-axis there because of the dimensions we lived in. But if we were to pull that graph out and break it into a third dimension, then you can see that it's going to have extra intersect points. It's a weird concept. If you want to know more, watch this video, but it does a great job of kind of talking you through those concepts and understanding where imaginaries come from. So the phrase imaginary is what scares us. Don't let it scare you. All right, let's get to it and see how this actually works. The problems are easy. Don't let that be hard. So up till now in your math career, you have been told that you cannot take the square root of -4. Well, you can take the square root of -4. We can take the square root of 4. Sorry, the square root of 4, that is 2. But because I'm square rooting a negative, we are going to include the letter I. The letter I represents the square root of -1. That's what I is. It's the square root of -1. And so what we did here was, instead of the square root of -4, we wrote it as the square root of 4 times the square root of -1. What's the square root of 4? It's 2. What's the square root of -1? It's the letter I, representing an imaginary number. So that's what we're going to be able to do here. Same thing on the next one. If we want to simplify the square root of -9, that is going to be 3i. Square root of -24. Well, that's not a regular whole number here. So I need to break down 24. I could break down 24 into 6 and 4, 6 into 2 and 3, and 4 into 2 and 2. I have a pair of 2's. These guys don't have a pair, so I'm going to multiply them back together and get 6. But because I took the square root of a negative number, we're going to include the letter I. All right, so we're going to put this I right here in front of the radical. That's always where we're going to put it. And otherwise, if we put it behind it, it looks like it's underneath the radical, and we don't want that. So that is 2i radical 6. -48, again, doesn't break down into a whole number. It's not a perfect root. So we are going to break 48 into 8 and 6. Break down 8 into 4 and 2. 6 breaks down into 3 and 2. I got a pair of 2's. I got another pair of 2's. So I got a 4 in front. This guy didn't have a buddy, so it's going to stay radical 3. But we took the square root of a negative, so we got to include the letter I in there as well. That is how you simplify radicals with a negative sign. Everything we did the same as before, just throw the letter I with it. So that leads us to this. Now we're solving. Okay, these are not problems that we have to use quadratic formula or factoring, because it does not have a linear term. It doesn't have x to the first power. So instead, we're just going to do like we did before and solve using square roots. We're going to do PEMDAS in reverse. So add or subtract. divide by 5, divide by 5. X squared is going to be equal to -1. So we added or subtracted, we multiplied or divided. Now we're going to deal with exponents. So to get rid of the square, we're going to square root. What is the square root of -1? Well, we know that it's going to be I, but since I took the square root, that means I need to include plus or minus. Because if it's a squared problem, I'm going to have two answers. In this case, it is plus or minus I. So just like before, when you take the square root, include plus or minus. Let's do it again. -72, -72, that's a 2. That's a 2. So 6x squared equals -72. Divide by 6, divide by 6. X squared is -12. Then we're going to square root. X is equal to, 12 doesn't break down evenly, so I'm going to go ahead over to here to the side. 12 breaks into 4 and 3. 4 breaks down into 2 and 2. So I'm going to get plus or minus because I'm taking the square root. I got a pair of 2s, so I got that. I'm taking the square root of a negative, so I'm going to include the letter I. And then the square root of what's left over here with the 3. So plus or minus 2I radical 3 there on B. Let's try letter C. Same thing, add or subtract first. So I'm going to subtract 16. Now I'm going to get rid of the square. So to get rid of the square, I'm square rooting. I'm taking the square root of -16. Well, I know what the square root of 16 is. That would be plus or minus 4. But because I took the square root with a negative, it's plus or minus 4I. The last thing I need to do is add 3. And be careful here. Technically, I'm taking 3 plus 4I and 3 minus 4I. I got to add 3 to both answers. Okay, you could have written it this way as well. You could have written 4I plus 3 and -4I plus 3. But we always put the real numbers, the things without an I, first in math class. So 3 plus or minus 4I. That is the best way to write that. We can't combine 3 and 4I. Those are not like terms. That's like saying 3 plus 4x is 7x. That's bad. Okay? Don't do that. Same thing. We're not going to add these two things together. So just keep that in mind as we work through that. Last one. Square root. That's going to get rid of the square. What's the square root of -25? That'd be plus or minus 5I, because I'm taking the square root of a negative. I'm going to subtract the 1 over. So -1 plus or minus 5I. Boom. Done. I'm just taking 5I minus 1 and -5I minus 1. I just wrote it in the correct way. That's not too bad. It's just a matter of doing it. All right. This time we are doing more quadratic formula practice, now with the possibility of imaginaries. All right. It is a trinomial this time, so we need to make it equal to 0. In order to solve this, you can either use factors or quadratic formula. If we tried to factor it, 10, what numbers multiply together get me 10? Well, 10 and 1, 5 and 2. Can I use 10 and 1 or 5 and 2 to get 6? No, you can't. So we tried to factor. Factoring didn't work. So now we're going to do quadratic formula. So remember what the quadratic formula looks like. -b plus or minus the square root b squared minus 4ac all over 2a. So -b, -6 plus or minus the square root of b squared minus 4 times a times c all over 2a. Do it the way we did it last, which was work underneath the radical first. So 36 minus 40, I get -4. I can take the square root of -4. I'm going to get two answers here. I got -6 plus or minus. What's the square root of -4? Oh, that is negative. No, it's not. It is 2i. The square root of 4 is 2. I took the square root of negative. That's why I included the I with it as well. All over 2. Can you reduce both parts by 2? Yes. So my final answer is going to be -6 divided by -3 plus or minus I, because these two right here would cancel. -3 plus or minus I is my answer. We had two imaginary answers, and I knew I was going to do that because the discriminant got me a negative number. Let's keep going. Letter B. Same thing. It's a trinomial. so I need it to be equal to 0. I could try to factor. We're going to assume it doesn't factor just because it says use quadratic formula. So negative b, so 3, plus or minus the square root, that's not b. What am I doing? That's b. 8 plus or minus 8 squared minus 4 times a times c all over 2a. Let's do what's underneath the radical first. 8 squared gets me 64. 2 negative signs, so 2 negative signs gets me positive. 4 times 3 is 12, times another 12 is 144. 64 plus 144. All right, so 64 plus 144 is 208. It's ugly. I don't know what the square root of 208 is. It's a decimal. So we're going to break down 208. Let's break it down into 52 and 4. We could break 4 down into 2 and 2. We break 52 down into 26 and 2. Let's break 26 down into 13 and 2. All right, that's all I can do. Looking for pairs. I got a pair of 2s. I got another pair of 2s, so I'm going to get a 4 out in front with a radical 13 underneath. Wonderful. I don't got any eyes. That's awful English. I don't have any eyes because my value here is positive. So it's 8 plus or minus 4 radical 13 all divided by negative 6. Can you reduce all of these numbers by the same number? And the answer is yes. I can divide them all by 2. And so I'm going to divide those 3 numbers by 2. 8 divided by 2 would be 4. 4 divided by 2 would be 2. And negative 6 divided by 2 would be negative 3. That's as far as I can simplify. That's going to be my answer. Is that ugly? Absolutely it is. If you want to know the decimal answer here, you would have to take 4 plus 2 times radical 13, get an answer, and then divide that by negative 3. It's rough, but that is the best way to do that. All right, let's keep going. We're almost done here, and then we'll flip into another video to deal with this a little bit more. X squared plus 2x is equal to negative 3. It's a trinomial. I need to make it equal to 0, so I'm going to rewrite this thing as x squared plus 2x plus 3 equals 0. I would try to factor it. Factoring is not going to work, so we're going to do quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. We do what's underneath here. I get 4 minus 12. I get negative 8. I'm square rooting that. I got a pair of 2's with a 2 left over, so it's going to be 2i radical 2. Looking at these 3 things, 1, 2, 3. Since all 3 of those things are divisible by 2, I can go ahead and divide them. 2 divided by 2 would be negative 1 plus or minus I radical 2. That is my final answer there. Yucky, but doable. Last one, I'm going to move fast. Negative b plus or minus the square root of b squared minus 4ac. That's not a. 4ac all over 2 times a. Underneath the radical first, I got 2 squared, so 4. I got 2 negative signs, so it's plus. 4 times 4 times 3. It'd be 16 times 3, it'd be 48. 52. I'm going to have 2 separate answers here. Or, I mean, 2 real answers here, no imaginaries, because that's not negative. So I get 2 and 26. And 26 breaks down into 2 and 13. Pair of 2's with a radical 13 left over. Negative 2 plus or minus 2 squared of 13 all over 8. Since these 3 numbers are divisible by 2, I get negative 1 plus or minus 1 square root of 13 all over. Obviously, you don't need that 1 right there. And then 8 divided by 2 would get me 4. That is my answer. Are these good, clean numbers? Absolutely not. Okay. A better way of finding these answers are probably using Desmos and understanding that. But the difference in Desmos is you are going to get a calculator or I'm sorry, a decimal answer. Well, these are simplified. So imaginary numbers, not as big as scary as you think. When you have a square root of a negative number, you put the letter I with it. That's it.